Can an EC centrifugal fan from another manufacturer replace an ebm-papst or Ziehl-Abegg unit? Yes, Longwell can provide replacement candidates for many mainstream applications. But a candidate should be released by evidence, not by diameter, wattage, or a familiar-looking connector. Start with the incumbent fan. Capture the full model code and nameplate, front and rear photos, the datasheet, the dimensional drawing, and the wiring or control document. Then describe the equipment, the air path, the problem you are solving, annual quantity, and every approval the finished machine must retain. One nameplate photo often establishes voltage, current, power, speed, and the exact variant, but it does not establish the installed duty. The first technical comparison is the operating envelope. Put the required airflow and the correct pressure definition on both fan curves. Do not compare a free air maximum from one sheet with an installed static pressure point from another. Confirm air density, speed, test configuration, inlet and outlet accessories, and whether the published value represents the complete fan assembly. ISO 5801 defines standardized airways for fan performance testing. AMCA's Certified Ratings program provides an additional verification route where a specification requires it. Never approve a replacement from one point alone. Check design airflow and pressure, a low-flow control point, and the worst credible resistance point, for example, a loaded filter or coil. At each point compare speed, electrical input, current, efficiency definition, stable operating range, and available margin. The winning candidate is the one whose curve survives the real operating map, not the one with the largest headline number. Next, perform a mechanical overlay. Compare impeller or inlet diameter, inlet ring geometry, and running gap, bolt circle, plate size, total depth, center of gravity, cable exit, guard, airflow direction, rotation, and removal path. A bolt pattern may match while the inlet ring creates recirculation. A fan may fit the opening but block the service panel. Record every deviation on a controlled drawing, use drop-in only after the actual interface has been verified. Electrical fit is a separate investigation. Match supply voltage, frequency, phase, protective earth, maximum current and input power, branch protection, leakage or inrush requirements, and the machine's EMC or harmonic limits. Check the candidate's permitted ambient temperature and any power derating. Similar-looking cables are not evidence of a compatible connection. Then inspect the control interface packet by packet. A label such as 0 to 10 volt, PWM, or Modbus does not prove the same pinout, command scaling, register map, addressing, baud rate, alarm logic, start behavior, minimum speed, or loss of signal response. Verify enable and stop functions, speed feedback, fault relay, reset behavior, and the safe state. If the incumbent uses a proprietary tool or network, define exactly what the replacement must reproduce and what the host controller must change. For acoustics, use the same measurement quantity and boundary. Sound power is not sound pressure at an unspecified distance. Compare the relevant operating points, frequency bands, tonal peaks, structure-borne vibration, and installed inlet or discharge conditions. A lower single dB number can still produce an objectionable tone in the finished air handler. Now review the environment and compliance file. Temperature, humidity, condensation, dust, corrosion, outdoor exposure, installation orientation, ingress protection, insulation, materials, fire behavior, and application-specific listings can all change the answer. A general HVAC fan must not be assumed suitable for smoke control, grease-laden air, explosive atmospheres, or another safety function without explicit approval for that duty. Qualification should move through 3 evidence levels. First, a document review with signed acceptance criteria. Second, bench testing of the candidate for airflow, pressure, input power, current, speed, sound, vibration, control, protections, and thermal behavior. Third, installation in the real equipment, followed by a pilot run across normal, part load, alarm, and worst-case states. Keep model revision, firmware, test setup, instruments, and results traceable. Only then compare total cost. Include engineering time, fixtures or wiring changes, validation, downtime risk, spare strategy, warranty response, and supply continuity, not only unit price. A well-qualified second source can create real commercial leverage, an unqualified equivalent can move cost into the field. So the decision is not which logo looks strongest. It is whether two products pass the same operating envelope, interfaces, environment, and validation plan. Send Longwell the current model or nameplate, 3 duty points, drawing, voltage and controls, required approvals, and the installation photos. We can return a replacement candidate and a project-specific verification checklist.